Okay, so we're going to try to solve the problem of how fast do you have to throw a rock for it to stay in orbit. Stay in orbit. Okay, and for this we're going to use our centripetal acceleration, a sub c equals v squared over r, that equation. So we have our Earth. It turns out that the radius of the Earth is 6,400 kilometers. I know that because I looked it up on Google. And what we want to figure out is if a satellite follows a circular path around, how fast does it have to be going horizontally so that it keeps on missing the Earth? Okay, so first off, as you may recall, well, what I would like you to do is see if you can figure this out on your own, okay? So pause it and see what you can do. This is the given information. I'm going to give you one more piece of information which may have occurred to you, maybe not. But the acceleration of this thing, the centripetal acceleration toward the center of the Earth is g, because that's how fast everything accelerates as it falls toward Earth. So that is equal to 9.80 meters per second squared. Okay, so we've got the radius of the Earth and we've got g, and we're going to figure out the velocity. Like I say, pause this right now, see if you can figure it out, and then we will work through it. Okay, so, right, this is actually pretty straightforward. A sub c equals v squared over r. So we get 9.80 meters per second squared is equal to v squared divided by the radius, which is 6,400 kilometers, times 1,000 kilometers. And then we're going to multiply that by 1,000 meters per kilometer, because we like we need our radius to be in meters if we're going to get meters per second squared for the acceleration. So this is just a conversion factor to convert kilometers into meters. Anyway, so that turns out to be 6.4 million. So we are going to take 6,400 kilometers times 1,000, that's the meters. We're going to multiply that by 9.8 to bring everything over to this side, and then we need to take the square root of it. So it comes out to be 7,900 meters per second is equal to v. That's it. So almost 8,000 meters per second. That's the accepted value, is around 8,000 meters per second is orbital velocity for the Earth. There's another way that you can see this. Let me go back to this slide here. If you look at the Earth and you do the geometry of it, if you drop an object, put it in free fall, it will fall 5 meters in 1 second. You probably recall that from the calculations we've done on free fall. We find that using the distance fallen is 1/2 gt squared, and if t is 1 second, it comes out to be 5 meters for the drop, pretty close, 4.9. And if you look at the curvature of the Earth and you do a straight line tangent and you go out 8 kilometers, about 8,000 meters, the curvature of the Earth will drop the surface of the Earth about 5 meters below that level reference point. So another way to say this is if you are looking at a sailboat sailing toward you over the horizon, if it has a 5-meter mast, that 5-meter high mast will disappear below the horizon when it gets 8 kilometers offshore. That's 5 meters from the surface of the water, obviously. So what this means is if you fire a projectile horizontally at 8,000 meters per second, in 1 second, it will go 8,000 meters horizontally, and in that same second, it will fall 5 meters. And that means that after 1 second, it's just as high above the surface of the Earth as it was when you fired it. So, and now it's going in a downward direction relative to you, but it's still parallel to the surface of the Earth. So after another second, it will have dropped another 5 meters, and the surface of the Earth will have also dropped another 5 meters. So the thing will never get any closer to the surface of the Earth. It will just follow the circular path all the way around. Now, obviously, again, like I said before, we can't do this, off the top of Mount Everest, even though there's no hills or mountains in the way, if you do this off the top of Mount Everest, because there's still air in the way, and air resistance will slow down your projectile from 8,000 meters per second, and it'll hit the Earth. You have to be above the atmosphere for this to work. So anyway, bottom line is 8,000 meters per second. That's our orbital velocity for our planet Earth.